Hello everyone, this is Amar. So in this video, we'll see another problem on shear force and bending moment calculations and drawings. So here you can see the beam diagram onto your screen. So we'll draw the shear force diagram and bending moment diagram from this beam diagram. So let's start the video with calculating the support reactions over here. So here you can see the diagram of beam. So a beam of length AB is there of distance 7 meter. So in this, at one end we have a hinge support and at another end we have a roller support. So hinge support can resist forces acting in any direction. So it is generally replaced by two reactions. So we have one vertical reaction RA and horizontal reaction RX. While roller support will always offer a reaction perpendicular to the beam surface. So we have only one reaction RB which is offered by this roller support. So we have to calculate the value of Rx, Ra, Rb, that is nothing but the support reactions. So for that we will consider the equilibrium condition of beam, that is we have three cases, that sum of horizontal forces equal to 0. This is first case. Sum of all vertical forces equal to 0, second case, and sum of moment at point A equal to 0. This is the third case. Now sum of horizontal forces equal to 0. So here we have only one horizontal force, that is Rx equal to 0 kilonewton. So the value of Rx will become 0 kilonewton. So sum of vertical forces equal to 0. In this case, the forces which act vertically upward will be considered of positive magnitude and the forces which act vertically downward will be considered of a negative magnitude. So in this case we have Ra and Rb are the vertical forces while 20 kilonewton is the downward forces. So Ra, Rb positive magnitude and this will be of negative magnitude downward force. So Ra plus Rb will become equal to 20. This is my first equation. Now taking moment at point A equal to 0. So moment is nothing but it is the product of load into distance. Okay. If the moment is clockwise like this, then it should be considered of a positive magnitude. And if the moment is anti-clockwise like this, then it should be considered of a negative magnitude. Now here, taking the moment at point A equal to 0, so the value of Ra into 0 will become 0. Now this 20 kilonewton load at 2 meter distance, because of considering A as a hinge, so because of this 20 kilonewton load, the beam will have this moment, like clockwise moment. Because of this load, it will have a clockwise moment. So 20 kilonewton acting at 2 meter distance. So it should be of positive magnitude. Then we have a couple 30 kilonewton meter acting clockwise. So clockwise positive magnitude plus 30. While this Rb load acting at 7 meter, because of this load, this beam will have the anti-clockwise moment. Because of this vertical load, it will have the moment anti-clockwise direction. So anti-clockwise moment should be considered negative. So minus Rb into 7 meter is the distance from point A. So equal to 0. On resolving this, we get the value of Rb to be 10 kilonewton. Putting in this equation, we get the value of Ra to be 10 kilonewton. So in this way, we have calculated the support reaction. The value of Rx is 0. The value of Ra is 10 kilonewton. The value of Rb is 10 kilonewton. Now let's start the calculating the shear forces. So we have shear force diagram over here. So shear force is nothing but it is the sum of all the vertical forces acting left and right side section of the beam. So here we'll take the shear forces at point A, C and B. Now let's start. So shear force acting at point A to the left. So to the left we have no load, so shear force definitely 0. So we have 0 kilonewton over here because no load is there. Now if we consider to the right of A, we can see 10 kilonewton load acting upward. So upward consider positive magnitude. So we have 10 kilonewton over here. So it is of positive magnitude. So we'll come above this 0 line, 10 kilonewton. Now considering at point C, so to the left of C, if we see, then we can see only this 10 kilonewton load to the left. So it is acting vertically upward, so of positive magnitude. So here we have 10 kilonewton horizontal line, 10 kilonewton at point C. Now if we take the right of point C, to the right you can see from right side you can see 10 kilonewton vertical load and 20 kilonewton downward load. So 10 vertical minus 20 downward will become minus 10 kilonewton. So minus 10 kilonewton means it will go below of this 0 line, minus 10 kilonewton to this side. Here we have minus 10 kilonewton. Now we consider the left of B. Again we have 10 minus 20 minus 10 kilonewton. So which will remain here minus 10 kilonewton. At point B we have horizontal shear force line. Now considering the right of point B, we have this 10 and 10, two vertical forces, 20 kilonewton downward forces. So 10 plus 10, 20, and this 20 downward, it will become minus 20. So 20 minus 20 will become 0 kilonewton. So here you can see at point B we have 0 kilonewton shear force to the right. So in this way we have drawn the shear force diagram. So here you can see above 0 we have positive magnitude and below 0 line we have negative magnitude. Now let's see the bending moment calculation. So let's start calculating the bending moment. Previously we have seen how to draw the shear force diagram. Now let's start calculating the bending moment at point A, C, D and B. So at point D we have a couple acting. So we are taking the bending moment at point D to the left section as well as to the right section. So let's start with point A. So bending moment at point A. So load 10 kilonewton is at distance 0 from point A. So 10 into 0 will become 0 kilonewton meter. So at point A we have a bending moment of 0 kilonewton meter. Now at point C, if you see to the left we have 10 kilonewton load acting at 2 meter distance. So this 10 kilonewton load will create the clockwise moment. So 10 into 2 will become 20 kilonewton meter positive magnitude. So we have a 20 kilonewton meter at point C. So here you can see at point C 20 kilonewton meter. Then at point D we will take the left section. So first we will take the left section. To the left you can see 10 kilonewton load at 5 meter distance will have a clockwise moment, and this because of this 20 kilonewton load it will have the anti-clockwise moment. So 20 acting at 3 meter distance from point D. So we have 10 into 5, then minus 20 into 3. On solving we'll get minus 10 kilonewton meter at point D. So we have here minus 10 kilonewton meter. So it will go below x00 line because of this minus sign. Now let's take the bending moment at point D to the right section. If we see to the right we have only 10 kilonewton load acting at 2 meter distance. So which will have the clockwise moment. So 10 into 2 will become 20 kilonewton meter. So here we have a 20 kilonewton meter at point D. Now lastly we'll take the bending moment at point B. So bending moment at point B will be what? 10 kilonewton at a distance 7 meter minus this will create anti-clockwise moment minus 20 at 55 meter distance, and then we have a couple which is acting clockwise plus 30. So on solving this we will get 0 kilonewton meter. at point B. So at point B we have a bending moment 0 kilonewton meter. So here you can observe in bending moment diagram there is a point Q where bending moment changes its sign from positive value to negative value at point Q. So this point Q is called as point of contraflexure. So we can calculate the distance of this point Q from point C. Now let's see how to do that. So that is point of contraflexure. Let us assume that from point C the distance is x meter, then definitely this remaining distance is 3 meter, means 3 minus x is the remaining distance. So for calculating the x distance we have here triangles. So we have two similar triangles over here, that is right angle triangle. This is one triangle, okay, this is one triangle and this is another triangle. So by applying the similar triangle law we have this 20 kilonewton meter distance divided by x. So 20 divided by x equal to this 10 kilonewton meter divided by 3 minus x. So this is by similar triangle law. So on solving this, 20 will go to this side, so 20 into 3 minus x, 10 will go to this side, 10 into x. On solving this, 20 into 3 is 60 minus 20x is equal to 10x. So 20 will go to this side, will become 30x after adding. So x on solving this 30 is a 2, so x equal to 2 meter. So 2 meter is the distance of point Q from point C, while from point D it will be 3 minus 2, that means 1 meter. Okay, in this way we can calculate the position of point of contraflexure. So hope you like this video. Thank you for watching.